So we have a real life repair. This was blown up because of operator abuse. The first stage FETs that are on this side, there's two pairs, but the one pair shorted out. It was a direct short. Then on the first stage, this one FET here, that was shorted. So a continuity test with an ohm meter is all you needed. All this could have been troubleshooted with an ohm meter, continuity test, and visual inspection. This FET showed that it was shorted, but once this FET and these FETs were replaced, it was actually okay. This little LM708 regulator, or 7805, excuse me, it's 5 volt. It's right here. It's right next to this board between two caps. That I noticed with the visual had a little brown dot, and when I ohmed it out, sure enough, it was shorted. Now it's because of this board here. That was shorted. Had a short in a 5 volt line. The 12 volt was okay. I think it's this chip. Later on, I'll see if I can replace this chip. It's the Brainzio operation, the EG8010, if memory serves me correct. I also added a socket, so you can just plug it in. That's not good for longevity, moisture, corrosion, but it's kind of handy for repairs. Tricky part that I found with the visual was one of these transformers. I don't remember which one. Apparently one of the leads was heating up, and then it melted the solder and made a solder blob underneath this PC board, and that touched another trace and created a direct short. Without schematics, I probably would have never noticed it and turned it on and had the same problem, although we'll talk a little bit about that with the power supply. But luckily, that's the importance of a good visual. Sometimes you can find things like that. Using the power supply, you can adjust how much current, so you don't, if you haven't fixed the problem, you'll hopefully not fry something, because you can limit the current and bring the voltage up slow and slowly charge up the caps, etc. Right here, there's in this area, probably can't see it, by this red cap, there's 2 wire loops, and right next to it, right in this area, right on the side of this red cap, is a surface mount diode. On this end of the surface mount diode and these 2 wire loops, which might be used for current sensing, is the voltage for the first stage. Manufacturer calls that the 250 volt DC point. Mine's 212, and they said that's fine. And if you look at it with a scope, there's just a slight amount of ringing of the MOSFETs on it, hardly any ripple. So I can't emphasize enough having a nice, well, it's really an inexpensive power supply, so you can bring things up slowly after you hopefully repaired it. That way, if you miss something like that solder blob, it's going to show up here. And also, there was one fuse blown. And I have a 100-watt light bulb. As a load, I just snapped on. So you can see the current went up. And of course the watts. So there's my 100-watt, and then there's 22 watts for running this guy. When you shut it off, you can see the current drops. And really it's only taking 12 watts now to run this without any load. and the voltage stays pretty stable. Of course, I'm not really loading it much. I really can't do that here. Let's see, we talked about the first stage FET, talked about the second stage FET, we talked about this voltage regulator, talked about the solder blob, the fuse, oh yeah, and we talked about this little PC board, socket added, visual, continuity test. So the only two things, really easy to troubleshoot, visual inspection and continuity. We talked about bench supply. Oh, these FETs are really hard to find. I couldn't cross them with anything. Of course, I could have got them from the manufacturer, but they only like to replace what's bad, and I want a supply of those. I only found one place. It was something like AliExpress from China. Must be a Chinese secret. The rest of the components I didn't have a problem with, and a lot of the other ones look okay. Of course, when you get into the real small ones, if you can't read what they are on the back, it could be a big problem. But hopefully none of those ever go bad. That's it. It was easy to repair except for sourcing parts and the time involved to get the parts. Nice thing is about electronic parts is you can put them in an envelope and ship them all over the world real easily. Thanks for watching.